Hello and welcome. Today we're going to solve a calculus PC question on differential equations. Here's the question. We have a ladder sliding off a wall with horizontal velocity of 1/2 meters per second. The ladder is 13 meters long and we are asked to find the ladder's vertical velocity at y equals 5 meters. So y is ladder's height and x is ladder's distance from the corner of the wall. This distance is x. How do we approach this problem? So I said that this question is about differential equations, but it's not about solving differential equations. It's about constructing differential equations. First of all, what does it mean to solve or construct a differential equation? Or what is a differential equation? A very basic example of a differential equation. Y prime equals y. So a differential equation is an equation that consists of a function and that function's derivatives. So this differential equation has y and y prime, which is y's derivative, its first derivative. So I'm not going to go into detail and tell you how to solve this differential equation, but I'm pretty sure you can guess its solution. So let's say that its solution is e to the x. Every calculus student knows that e to the x is its own derivative. So if I differentiate it with respect to x, it's just itself. So e to the x solves our differential equation. Plug in e to the x for y, and its derivative is equal to itself. But is it the only solution? No. We have e to the x, and we plug in, it solves, it satisfies the differential equation. Let's say we have 2 e to the x. What is the derivative of 2e to the x? It's still 2e to the x because the coefficient doesn't have any effect on the differentiation process. We still differentiate e to the x and it's still e to the x, and we multiply it by the coefficient. So 2e to the x's derivative is itself. So also this function satisfies our differential equation. So to solve a differential equation means to find a general solution, which is c e to the x in this case, because any constant number satisfies its differential equation. If in the problem we are given an initial condition such as f of 0 is equal to 3, this says that we have a function which satisfies this differential equation, and when we give 0 as an input to this function, we get 3 out of it, which means we have this general solution here. We said we give 0 to the x, c e to the 0 is equal to 3, e to the 0 is 1, and c is 3. So, solution of this differential equation with this given initial condition is 3 e to the x. What we did, we had a differential equation, an initial condition, and we solved our differential equation, found a function that satisfies the differential equation. This is what is solving a differential equation. Actually, most of the differential equations are much harder than this, and much more advanced techniques must be used to solve the differential equations. But in our question, we don't need to solve a differential equation. We need to construct a differential equation. And here's how we're going to do that. We need to find a relation between x and y and their derivatives. Only relation we can find from this question is that if we treat this shape like a right triangle, then the square root of x squared plus y squared is equal to 13. This is just Pythagorean theorem. A squared plus b squared is c squared. To get rid of this square root, I will square both sides. And I get this equation. If I differentiate the whole equation, I get a differential equation. And to differentiate the whole equation, we need to use implicit differentiation, because we have both y squared and x squared, and we need to treat both variables as outputs, as dependent variables. Not in any function we have y, which is dependent to the x, so x is independent variable and y is dependent variable. But in this question, x and y, they both depend on time. We need to take their derivatives with respect to time. So we differentiate x squared, which is 2x, and multiply it by dx dt. This is implicit differentiation. I use the same method for y. And derivative of any constant is 0. Here, I get a differential equation, and I don't need to solve this differential equation for a general case. I'm given an initial condition, y equals 5 meters. So I just need to plug this value into the differential equation to find this specific dy dt at y equals 5 meters. First of all, I have dx dt, which is always 1 over 2. So I can replace dx dt with 1 over 2, and I get and I'm going to replace y with 5 meters for this initial condition times dy dt. It's 0. So if I rewrite this equation up here, it's x plus 10 dy dt is equal to 0. 10 dy dt plus x is 0. I have two unknowns. One of them is the velocity of the vertical velocity of this ladder, and the other one is the horizontal distance between the corner and the ladder's tip. I can find what x is. If y is 5 from the Pythagorean theorem, x is 12 in this case. 12 plus 10 dy dt. And now I actually solved the question. I can send 12 to the other side. 10 is equal to minus 12, and divide both sides by 10, and I get minus 6 over 5, which is our answer. What does this mean? What does minus 6 over 5 mean? It means that our ladder's vertical velocity is minus 6 over 5 meters per second when the vertical distance or height of our ladder is 5 meters. What did I just do? I constructed a differential equation. I didn't solve it for the general case. I just plugged in the initial condition and solved it just like a normal algebraic equation, and got the vertical velocity of the ladder at y equals 5 meters.